Okay, I start recording. So what actually we have discussed, what you actually have discussed in several times. So this is the third attempt. So as I discussed in that, why operating system is system dependent, the main reason is whenever you install any operating system to any machine, the operating system actually make all the environment, take all the necessary utility software, device driver software, and all other software, and install it only for those machines. For example, your network card, your motherboard, your types of memory, your hard disk, your other devices, and then make an environment. So whenever you change your, you take your operating system to the other machine, it will not work because the system, because the hardware into the first PC or the first machine is not the same of the second PC, because operating system totally actually depends on which equipment you are actually using. Okay, so that's why we said that operating system is totally system dependent. That's why if you change the hard disk from PC1 to PC2, generally it will not work because the systems are different, because the machines are different. So that's why we call the operating system a system dependent. Although I told you again, previously that some of the operating system have a very few feature, exceptional feature, by which you can carry your operating system from one system to another system. But that is a very few, and that is a very exceptional one. For example, Ubuntu also, you can carry your operating system with a USB drive, your Ubuntu, and you can plug and play anywhere. But that is an exceptional case. Generally, operating system is not plug and play. Yesterday also I have discussed about plug and play. Can you remember what is plug and play? Anyone? Plug and play. For example, my monitor is plug and play. My wireless mouse is plug and play. So what does it mean, plug and play? It is also depends on the operating system. What is it? Anyone? What is plug and play?
Sir, the generic driver for your device is already installed on your computer.
Already installed my computer? Is not already installed my computer. Did you see? Did you see that whenever you first attach the USB dongle of your mouse, and there is a, on the bottom right corner, it says actually there is a new device, or there is a settings, right?
Yes,
it will take 5, 10, 30 seconds to install it, and then now it says that your device is now ready to use. Did you see?
Yes, sir.
All right, so that is actually plug and play. What actually plug and play is, it is not automatically working. Is our, as I said, that our current operating system are very smart. Previously, I gave the example yesterday that whenever I use my first computer in 2002, right? In 2002, my motherboard has a CD, installation CD, my sound card has installation CD, my other floppy drive and all other things had different CD, and I need to install those CD one by one whenever I install my Windows operating system. But now what actually happened, for example, my new PC, when I buy this new PC, I also have motherboard CD and all other CD, but this time I don't need to do anything, because now our operating system is very smart, that the operating system install all the utility software, all the necessary software for me, so I don't need to install it by myself. So the operating system do it for me. That's why it is called plug and play, because whenever you plug something, our operating system is very smart. It can detect the new hardware and then go to the internet, or maybe it has its own devices, and then install the driver by itself. So that is actually plug and play. Nothing is automatic, right? Previously, human needs to install it, but now operating system install it for us. That's why it's called plug and play. Okay, so there is also, but it is not like that, that it's still system dependent. For example, if you change the mouse, to the other PC, right? If the operating system cannot detect it, if the operating system does not install the device driver for the wireless mouse for the new PC, your mouse will not work. Okay, so that is the system dependent. All right, I hope you understand. If you still have question about the operating system dependent or system dependent, let me know. Hardware, of course. For example, why hardware is actually system dependent? Can anyone tell me then why hardware is system dependent? Or how it is system dependent? For example, I have a graphics card, right? I have a graphics card into my PC. I plug out my graphics card and attach to another PC to the graphics card. What will happen? As I said, the hardware is of course system dependent, because in my PC the graphics card is working very fine because I installed the driver and everything. But if you plug out and put it into another system of the graphics card, what will happen? What do you think?
If you don't install the driver on the other PC, it will not work. But if you install the driver, it will work.
Exactly. So if you don't install, or if the operating system in the other PC does not install the driver for that graphics card will not work, although it was working into your PC because your PC already installed it. So that's why that is an example. That is a good example of system dependent. That means that graphics card only works in your PC because your PC knows it. Your PC already installed the device driver. All right, so this is called the system dependent and everything. So just remember from level 0 to level 3, 0, 1, 2, 3, this is all system dependent. So if you change the system, you need to change your code, you need to change the way you need to use it, then it will work. For example, if you write the assembly language into this PC, my PC, and if you take the code from the USB and try to run it into the other PC, sometimes, most of the time, it will not work. So what actually you need to do to make it work? You need to change a little bit of the assembly language. And before that, you need to know what is the new system. You need to know what is the processor or memory of the new system. If you know it, and if you change according to the new system, then it will work. Okay, so that's why it is system dependent. I hope you can have an idea about the overview of computer system, right? Because, by the way, the picture you are actually watching, this one, you will see this picture at least 3 to 4 times in the next 4 or 5 courses, because it's the same one. It will work in operating system. The same thing you will see in the microprocessor, now in the assembly language also, and many other, because it's a very, very important one for your next semester courses. So make sure you know this one very well. If you know this one very well, these levels, high level and low level, and all others, level 0 to level 5, I think it will not be a problem for your next study. Okay. Any question related to this overview of computer system? By the way, this is everything from the book. You actually can find all the description, everything in that book, chapter 1. As you can see, is a figure 1.1. Any question related to this? Please ask me. Otherwise, I can go to the next.
Sir.
Yeah.
Sir, there is a thing that names operating system calls in level 1.
Mm-hmm.
Is this the kernel of the operating system?
Yeah, I think about the operating system and everything, yes. Any other question? By the way, you need to respond, all of you. Otherwise, I actually cannot understand, because as you know that it's, for me, it feels like I'm talking to my computer. So there are, how many of you are here? 41. So please let me know you are fine with whatever we have just discussed. So it's in the overview of the computer system. We discussed that what is number 4, number 5, what is the difference between number 4 and 5, and also 0, 1, 2, and 3. Okay. Okay, if we are comfortable with this one, I think we can go to the next one. Right. So now we can start that what's actually assembly language. We from the previous discussion, we know that operating system, assembly language is of course a low-level language. Why we call it low-level language? Because we have a very deep relation between the assembly language and the system. we actually can have a very good control of the system. So whenever we say system, that means it's the architecture of the microprocessor, it's the type and architecture of memory, it's also the type and architecture of the data bus and everything. So whenever we say that it is we need to know about the system, so that is actually the system. So as you can see that assembly language is a low-level programming language. This helps the understanding the programming language to the machine language. That means it's actually convert our assembly language into the machine language. By the way, okay, can I ask you, do you have any guess that what is actually the difference between assembly language and machine language? Anyone?
Yes, sir. Machine language is just 1010, and in assembly language there are very basic words like add, subtract.
Yes, correct. Anyone else? Anyone else? Only Mahmoud Hassan is responding. Anyone else? We have 41 here, so you should 40 here.
Sir, assembly language is a low-level language.
Okay. I mean, what is the difference? Both of them are a low-level language, assembly language and
Sir, assembly
machine
language is a low-level language, and sir, machine language is a binary form language.
Okay. Anything else? Yeah,
Sir.
good. Yeah, fine. Yeah, anything else?
No, sir.
All right. Anyone?
Sir,
Yeah,
machine, sir, machine can directly understand the machine language, but
yes, very good.
in assembly language, it cannot understand. We need a assembler to convert that assembly language to machine language.
Exactly, correct. Yes. For the machine language, you are very right. The machine language will directly understand by our hardware, whereas our hardware actually cannot directly understand the assembly language. We need a assembler. That means is actually an intermediate thing which actually converts the assembly language into the machine readable machine language. Yes. Anything else? Anyone? Thank you. Yes, dual runner. Dual runner, or which is Afsana? Yes, Afsana.
I have a question.
Sure.
Sir, why do we need assembly language to learn? I mean, we can, can't we do C or Java to work with the computer? Why do we need to learn assembly language?
Very good. Good question. Your answer is actually here. Here we have here also. So please wait while programming in assembly language. We will discuss. Okay. Your answer in the next slides. Very good question, by the way. We will discuss. So thank you for asking. Anything else? Anyone? No? Okay. So what is assembly language? You are absolutely right that assembly language is a low-level language and is convert the assembly language into the machine readable machine language or machine code. Okay. So, and also another very good and important characteristics is the second one. Look, it says that is direct influenced by the instruction set and architecture of the processor. That means other programming language does not have that much influence to the instruction set or the architecture of the processor. But the assembly language actually have a very good control over all this. Instruction set means that we have some of the instruction how our hardware will work. That is the instruction set, and also the architecture. We know the architecture of the processor. Okay, and that is an example. Let's see the example. Okay, look at this for INC. Result is a variable. Move is a variable, that is a number. And by the way, INC, MOV, AND, and ADD, these are some keywords for assembly language. And the others, because assembly language starts with this word, we should have a keyword like that. And then we have our variable. So as you can see, we have a keyword first, and then we have a variable. Keyword, variable, variable. Keyword, variable, variable. So the first one is actually a keyword, and then variable, variable. Generally in assembly language, by the way, yesterday I told you that we have two types of processor. Can you remember the two types of processor yesterday we have discussed?
Yes, sir. CISC and RISC.
CISC and RISC, yes, correct. So as we know that assembly language is totally depends on the types of the machine. So the assembly language coding for CISC processor and the assembly language for RISC processor, they are not same, they are different. Okay, so whatever you are watching now, this is actually the program for CISC processor. By the way, the example of the CISC processor is our normal PC processor. Right? Our normal PC processor, for example, our Pentium Core i5. So that is the CISC processor, and the RISC processor maybe in the embedded system,
Mobile phone, tablet, sir.
yeah. Though all of the small one where actually we don't do that much, although there are some exceptions. Okay? We will discuss more about CISC and RISC very widely soon. All right. So just keep in mind that we have two types of processor, RISC and CISC, and their assembly language code is also different. So what you're saying, these four, INC, move, add, and add, these are for the CISC processor. So let's see what does this mean. Look at the first one, INC, and this is a keyword, and then we have a variable. What actually it does mean? Look, it's actually mean, INC means increasing. So if you convert this one into equivalent C or C++, we actually can write resolve plus plus this one. That means in C we write resolve plus plus, right? That means we increase one. So the same thing we can write it in the assembly language like this, INC result. I hope you can see the difference, right? So let's go to the next one, move, and add. Look, the second one. As I said, the first one is our keyword. Then we have two variables. So the first, the one is the keyword. It says the move. That means we move from one place to another place, right? This one to this one. So if you want to write it into the C, we actually can write this one, this way. That means assignment. We move this variable into that variable. That's what it means, move. What about AND, A-N-D? It's actually logical AND. If you think about the logical AND, we know about logical AND. So you actually do logical AND of this variable and must one, this variable. If you want to write it in the C, it will be like this. So logical AND operation, all right? Or you can see the bitwise AND operation. Bitwise AND or logical AND operation. That is the third one. And if you want to go for the fourth one, which is add, the keyword is the add, and we have two variables. Marks is a variable, and 10 is another variable. So if you want to write this one into the C equivalent programming language, it will look like this. So we add 10 with the marks and put the value into the marks again. So that's how we actually can write the assembly language for computers. By the way, let me remind you again, this is only for Pentium language, Pentium processor. Pentium means whenever we say Pentium, that means it's actually CISC type of processor. Complex instruction set computer types of processor. That means it's a Pentium processor. If you want to write the code into the RISC processor, let's see how does it look like in assembly language. Look, by the way, all of these examples are from the book. You actually can read it from the book also. Okay. So look at it now. We have 3 examples here. So this is example 1, 2, 3 examples of RISC type of processor. By the way, I hope you can still remember in the RISC is types of architecture how the processor can be built. So that type of, by using the RISC type of processor, there are so many types of processor. For example, ARM, ARM-T, PowerPC, MIPS. So MIPS is another, subcategory of the RISC processor. MIPS means multiple instruction per second instruction. So it's a very popular one. for the RISC types of processor. We will, in this course or in this book, we will always discuss about the MIPS instruction because it's very popular, and most of the current microprocessor are using this kind of MIPS instruction. That's what we are doing. So let's see, what is it? ANDI, there is a sign, there is a variable. So sign, this sign actually means it's actually a variable, right? So and also it's actually thinks that it's actually a register variable. Okay, all right.
Processor register.
Yeah. Okay. So as you can see, we actually have two of the variables here, and we have another value. Second one, ADDU add, and then we have again 1, 2, 3 variables. How do you know it's a variable? So we know that we have a $sign here. So $sign means actually a register or processor register or identifier. Okay. Think about the third one, move. Again, we have 2 variables. Let's see what actually it does mean. If you can see that ANDI, right, is actually doing an AND operation, right? AND operation. Then previously we actually have 2, 1. Like we have, if we can see, AND operation, we actually have 2 variable for CISC processor, but RISC processor AND operation we actually have 3 variable. That is the difference. Okay, what does it mean? We actually do the AND operation for the T1 and with the 15 and then store it into the T2. Okay, if you think about the second one, ADDU, add U, that means we add T1 and T2 and then store it into the T3. Okay, the move operation. We actually move this variable into that variable. That means we move, or the copy, whatever, the T1 value into the T2 value. So that actually does mean, and I told you that this is actually MIPS instruction. There are so many differences between the MIPS instruction and the CISC instruction. Okay, they are completely different. If you write the same code into if you write this code into MIPS architecture processor, it will never work. Same again, if you write this code into Pentium processor, it will never work. Okay, because those are completely different architecture of or different types of the processor. So that is actually the example that how we are going to write assembly language. More or less is almost same, like AND operation, move operation, increment operation, add operation, but little bit change depends on the RISC and the CISC. Okay, I think you have a little bit idea about the assembly language. Please let me know if you have any question related to these types of example of assembly language. Any question, please? Or you have another class? Oh yeah, sorry. Thank you for reminding me. Yes, Afsana.
There was written that some Pentium language.
Pentium processor, yes.
Pentium language, there was written in the slide that Pentium language. Is it a language or processor? I mean
yeah.
Is it a different language for CISC processor?
No. Pentium language means it will work in Pentium processor. That's why it says Pentium language. It means it will work in Pentium processor. That's why it's written Pentium. Let me, so the time is up, so let me give you the attendance. Please unmute your microphone and let me give you the attendance. So please respond. Jewel Rana?
Yes, sir.
All right.
Yes.
Shahadat Ahmed?
Yes, sir.
Alif Raila Jannat? Alif Raila Jannat? Sanjida?
Yes, sir.
Shiraj Munira?
Present, sir.
Khairul Islam? Khairul Islam? Ashikur Rahman?
Yes, sir.
Sir, Fazil Karim, sir.
Ashikur Ashikul Rahman is fine. Okay. Faiz Karim.
Yes, sir.
Husniara?
Yes.
Okay. I got you. Rakib Mahmoud. Yes, Husniara, I got it. Rakib Mahmoud. Absent. Nazmus Sakib. Absent. Atikul Hassan.
Present, sir. Atikul Hassan.
Okay.
Atikul Hassan, sir.
Okay, all right. Thank you.